Okay, hello Chem AP students. I'm Mr. Hevel,
And Mr. Moore.
and today we're here so that we can videotape your first lab. Okay, but we got to give you some background so you have an idea what's going on. So, I believe this reaction that you're going to use involves a double replacement reaction.
Double replacement reaction. You remember what that is?
If you don't, go look it up. Okay, and because we're going to make a precipitate for this reaction, we can capture the precipitate on a piece of filter paper. All right, and we have to show you a new lab technique that we use to help that along. Okay, so the College Board would refer to this as gravitometric analysis. Okay, we're going to use the mass of the precipitate to help us calculate something.
Sounds good. Yep. So what kind of equipment do we have for gravimetric analysis?
Yeah.
We have one of these. A normal flask is not quite normal. It has this sidearm on it. So you can, we'll do something with that. There's going to be a funnel that has a stopper that it's going through so that we can make a good seal between the funnel and the inside of the flask.
And we have a piece of filter paper, again, that will be in the funnel to capture our precipitate. And if we did this using gravity to pull the water through, it would take a long time. And Mr. Moore has a lot of patience. I couldn't wait that long. So we're going to use something called suction filtration.
Yep.
And I don't know if they can see it because we're a long ways away.
Yeah.
On the faucet, there's a device called an aspirator, and it's what's going to generate the suction force. So let me just show you real quick what's going on there. So if we turn the water on, the water rushes through the nozzle, but it pulls air through this sidearm. And you can tell that because when I plug it up, the water slows down. Okay? So the idea is we're going to hook this heavy-walled vacuum tubing up to this sidearm, and we'll connect it to the flask.
So that creates a vacuum? That's pretty cool.
Yeah, here, we'll check it out. Here, let me take the funnel off for a second.
Yep.
If I turn the aspirator on, put my hand over it.
I can hear it. Yeah. Oh, how nice.
Yeah, you hear the popping noise? Yeah. So we can generate vacuum, and that will help draw the water through so we don't have to wait as long.
Doesn't that waste a lot of water, Mr. Hevel? What about the fishies?
Well, you know, it all goes back to the same place. It's going to go down the drain
Oh, okay.
and go out to the lake.
Okay, all right.
And chemistry is more important than anything. So
Absolutely it is.
the fish will figure it out. Okay, so let's show you what a difference it makes, though. And I wish you were here live to be able to do this, but we have to put the piece of filter paper in the funnel and get it to seal tightly. And so we'll fold it in half once, fold it in half twice, and if we pull 3 of the 4 edges together, we get a nice
Oh,
cone
yeah.
shape, and that'll fit inside that funnel tightly. So normally what I do,
We use a little water to
Oh, yeah, there we
help
go.
that stick. We wish you were here for
Yeah.
this. You need to be doing all this yourself.
yeah, so usually I soak the filter paper down and I press it tightly into the funnel. We want a good seal. We don't want any air rushing behind the filter paper because then we lose suction power. So if I put some water in here, okay, I don't know if you can see this, the water dripping through. I don't know how well it's showing up. If I put my hand back there, can you see the water drips coming through? Notice the rate they come through. It's not real quick, and once you get precipitate on the paper, it starts to plug it up, which slows it way down. But now watch, I'll turn on the vacuum,
Wow, what
and
a
all of a
difference.
sudden, pow, the water just gets pulled right through. Okay, it speeds things up quite a bit. Okay, so that's suction filtration. We're using this technique to help us capture the precipitate that the reaction generates.
And it goes a lot faster with the suction.
Yeah.
We can't stress that enough. We would be
Yes.
sitting here for a
For a
long time. Yep.
Yes, it would not be good. Okay. So let us tell you some more information. What, did we forget anything there?
I think, no, that's going to get us our precipitate, and we'll filter everything that's dissolved right through the paper. The paper
Yes.
only catches the solid
I did say that.
precipitate, and everything else goes through.
Right, anything that's aqueous runs through the paper.
Yep.
Yep.
So should we talk
Yeah.
about the specific lab?
Yeah.
All right.
You want to stand or you're just gonna?
No, I'm just going to hold it.
Okay, so there's a little bit of information you need. Last year, we used solubility a little bit, but it's important to know this. These ions are always soluble. Group 1 metals, the ammonium ion, and the nitrate ion. You need to know that, okay? Here's what you're going to get. You'll see this in a minute. We mixed 2 ionic compounds together. There's potassium chromate and barium chloride, right? They're both solids. We mixed them together to create the sample, okay? Another very important item to know is that potassium ions, barium ions, and chloride ions are all colorless in solution. But the chromate ion looks yellow. It's a very noticeable yellow color if it's present in solution. Okay? So what's going to happen here, and you'll see this in a minute, we have a sample that has these 2 solids on a piece of paper, okay? Essentially, we're going to dissolve it in some water. The double replacement reaction will happen. A precipitate will form, and then we're going to filter out that precipitate. Okay?
Yeah, double replacement, remember, the positive ions switch places.
Something like that. I get confused.
Yeah.
Yeah.
I'm just trying to work that out in my head.
Yeah. I mean, you haven't done this in a year, so.
It's been a long
I
time.
forget,
Yeah. Okay. So that's what we're up to. Let's see, there's already a sample that has been measured out
Yes,
and
there
waiting
is.
for us.
Yep. Normally, if you were here, you would get every lab group would get his very own sample to use. And so, Mr. Moore and I are the lab group now.
We'll see how we can botch this up
Yeah.
for you.
Oh, and we will. Okay. So here's the sample. I don't know how well it shows up at all. Not this way. So on a piece of paper.
Yeah, you know what, I can tilt this down. See it.
Yeah. I think, oh, now we have a ton of glare. You
Okay.
can't see anything, I don't think.
Ah,
Okay.
there it is.
There
There's
you
the
go.
sample.
Okay, there's the sample. Okay, again, it's the potassium chromate and barium chloride mixed together on this piece of paper. Okay? Now, it's probably important for us to know the mass of this sample to start with.
Yeah, we
Okay?
probably ought to know that.
Probably ought to know that. So we got a balance here, a scale.
We're going to dissolve that sample in water, so we'll use a beaker. Put the beaker on the balance.
Should we move it over
Yep,
closer?
I'll bring it over.
I can move this.
That's all right. Well, I'll need to pick this up to be able to see the mass on there.
Oh, I guess so. Okay, so here's the beaker.
Yep,
We
that
use
mass doesn't matter so much. We'll just zero out the balance,
Okay.
and we'll add the sample now to the beaker.
Okay, we ready?
Yep.
Okay. And, oh, I took it off too
Not so
quickly.
fast, Mr. Hubble.
Sorry.
There's our mass of the sample. We had zeroed the beaker out, and that's just the mass of the sample.
Yep.
Okay.
So now remember, double replacement reactions occur aqueous. So we're going to add a little water to this. dissolve the sample.
We don't want to use too much water because it takes too long to filter it out.
So definitely is cloudy. There's no question there's precipitate in there.
Yep. So the original ions dissolve, and then now there's a precipitate. that's
Yes. Okay. So now we're ready to filter. So I'm going to grab some filter paper.
made. Yep. You think we should take a mass of the filter paper?
Do you think we really need it?
I think we probably would.
Do we? Okay. I always trust Mr. Moore's opinion, so. Whoops, I got to zero the balance.
Well, we got to watch you, Mr. Hubble.
I know.
It's Friday afternoon late. That's probably a good measurement to make.
Yeah,
mass of
you're
the
probably
filter
right.
paper.
You're probably right. Okay.
Got another trial going on over here.
Yeah, that's the last one. Okay. So, remember we have to get our filter paper into the funnel. So as we did before, we'll get it folded. And, let's see if we come up. Okay, I'm gonna wet the filter paper down because we want it to stick to the funnel. So see the suction pulling the water through. Make sure you got a tight fit.
Yep. And Mr. Hubble is doing this on purpose. You can see he's got his, he's checking to see if all the students are paying attention to his safety practices.
That's right. Safety glasses.
Right?
They protect your forehead, but better if they protect your eyes.
They do look pretty good up on the forehead, though.
They do. Okay, here we go. We're ready to start.
Ah, the glare is,
Glare's bad.
yeah. But we can see that yellow stuff that's going through.
There's some yellow stuff too. Right, so the liquid that's flowing through is called the filtrate. And even though it might have some color, it's important that it's clear. We don't want to see any cloudiness. We don't want any signs of precipitate coming through down here. I wonder if the fact that the filtrate's yellow is important.
Well, it definitely is yellow, isn't it?
Definitely is yellow. And you want to gently add the liquid. You don't want to get above the top of the filter paper because then you get water that runs behind and you'll lose some precipitate.
Yeah. But the common mistake, too, people will try to fill it up all the way to the top of the funnel just to make it go faster, but that's a terrible mistake.
It is.
All right, we'll come back when we're just about done filtering this. Yeah, we're down to the end of our filtering sample.
Yeah, we've been scraping with the rubber policeman and using a little water from the wash bottle.
Very nice clear filtrate. Clear meaning no fogginess, cloudiness in it.
Maybe give it one more tiny squirt, Mr. Moore.
Yeah, because our results depend on getting all of that precipitate out of there and into the filter paper, which we'll let sit and dry over the weekend.
See it?
Yep.
Okay. think it's a winner.
Yep. So we'll get the rest of that through, the rest of the water and dissolved stuff through, and then we'll just lay it out on some paper towel and measure the filter paper plus the precipitate when we're done, when it dries. Here's our sample after it has dried all weekend. It's now Monday. You can see that the paper is curled up some from being wet originally. Our precipitate has made a thin coating on it. And we need the mass. Here's our balance. And the mass of the filter paper plus that dried precipitate is there.